All right, hello once again. This is Jeff Scott of Rankin Technical College. And as part of the Rankin Technical College AWD, or Application and Website Development program, and in particular the AWD1100 C# Programming Fundamentals class, I've been doing a series of video presentations based on the textbook for the class, that being Murock's C# 2015. And right now I have done lectures on Section 1, Chapters 1, 2, and 3 in Intro to Visual Studio. Section 2, Chapters 4 through 11 on the C# language essentials. And I'm in Section 3. And in particular, I've done Chapter 12, and now I'm about halfway done with Chapter 13. So I'm going to continue on with that right now. So there's a couple ways. We were talking about delegates. And they mention here there's a couple different ways that you can create delegates. All right. Again, this looks similar. Of course, not identical, but it looks similar to when we did stuff like this in JavaScript, and we used an anonymous function. Here we're using an anonymous method, so it's a method that doesn't have a name. All right. So you'll notice my delegate equals delegate, okay, no name there, and you do whatever it is you want to do. With a lambda expression, typically what you do is on the left-hand side of this lambda operator, which is an equal sign followed by a greater than sign, you put where the result should go. And then on the right is what you want to do to get there. All right, hopefully that made at least some sense. So we just looked at an anonymous method and a lambda expression, and here's how you would wire those up. Again, I think we're going to have to be going through detailed examples if we go to this extreme in here. All right. Operator overloading. Well, what you're doing with operator overloading, we looked at an example a little bit earlier where we used the plus sign to add a product to our product list, and a minus sign to remove a product from our product list. What we're doing is we're overloading plus and minus. In other words, plus isn't being used for straight addition, minus not being used for straight subtraction. When you want to be able to use operators to work on an object, you overload those operators. Here are some of the operators that are commonly used for overloading. All right. So notice here's a couple of examples. Equals returns a Boolean value that indicates whether the current object refers to the same instance as the specified object. Equals with two objects. It'll compare two objects to determine if they refer to the same instance. Get hash code, which returns an integer value used to identify the objects in a hash table. If you override equals, you must also override the get hash code method. And they give some examples. Again, this, in my opinion, is about as heavy as it gets. Notice what we're doing here. We're telling it to override the plus method. All right? We're passing in a product and the product list, and we're telling it to add the current product to our current product list, and then return our product list. All right? Now, another way you can do this is, rather than just plus, is you can overload plus equals. You're going to end up with something very similar, but it's just another way of doing it. All right. Yet another way of doing it here. Here's one that overloads the double equals operator. All right. To see if two objects are equal to one another. And I believe in this case, it's do they point to the same reference or do they not? Remember, when you overload the equals, you have to also overload the get hash code method. All right. So it says here the code for the product list class. Let's take a look where we are here. This is an enhanced version of the product maintenance application. The author says on page 430, now that you've learned the techniques for enhancing your classes, the topics that follow present an enhanced version of the product maintenance application that uses those enhancements. From the user standpoint, the application should operate exactly like the one presented in Chapter 12. The only difference is that the classes in this version are implemented differently. Specifically, the product list class includes the additional members that are shown here with the delegate with the event. But again, it should work the same way as what we did previously. Now, probably in your opinion, this was a watered down talk going over this chapter. And you know what? If you think that, you're correct. All right? Because again, my concern is this book has in it, if you include the diction or the index rather, about 880 pages. And although you as students may be good enough to go over 818 pages or 882 pages in 16 weeks, which comes out to about 55 pages a week, I don't think I'm that good. All right? So again, I don't think I'm going to be spending much time on the chapter we just went over. I will plan on spending more time on Chapter 14, which is the next chapter. Chapter 14 is on inheritance. Inheritance, encapsulation, data hiding, polymorphism, etc. Those are some of the hallmarks of being able to use object-oriented programming. I'm not saying delegates, indexers, etc. Of course they're important. There are things that are provided to make it easier for you. All right? Whether we go over that chapter or not and how much depth and breadth of coverage we go over that chapter and Chapter 15 remain to be seen. All right? But I'll be back in a bit with Chapter 14, how to work with inheritance.